Hi, welcome to my YouTube channel. Um, just in front of you is a football. This football is a classical example of a sphere. What we are interested in is to determine the surface area of this sphere. The best way to explain this is to explain it this way. If I'm going to determine the surface area of this sphere, let's say I am standing here before you. If I'm standing before this, if I'm standing here, okay, if I'm standing here, I'll be seeing a surface here. Where I am standing right now, I am seeing a surface. If I were to stand here, I'll see another surface. If I go this way and stand here, I'll see a surface, which means if I go in these various positions I just described, I'll see four surfaces. Okay? And each of these surfaces are circular surfaces. We already know that the formula for calculating the surface, the circular surface, or the formula for calculating the area of a circle is pi r squared. It means if this represents a sphere, the four surfaces I saw, if I'm going to calculate the surface area of this sphere, surface area, surface area of the sphere, let's say we actually see a surface here. Okay, it's not really a circle. We are seeing a surface, okay, where all these ones are also surfaces, and I have a radius to the surface also. The surface area of the sphere is equal to the curved surface of the sphere. All right, it is the curved surface or area of curved surface of the sphere. Now, when I stood describing with this football, okay, here I see a surface, there's a surface here, there's a surface behind, and there's another surface here. We can now see that for each of the surface that is here, we have a circular surface, which is the area of a circle. So for four of them, we are having pi r squared plus pi r squared plus pi r squared plus pi r squared. 1, 2, 3, 4. That will give us 4 pi r squared. This is the formula that we will use to calculate the surface area of a sphere. Now, if we decide to cut this sphere in such a way that we cut it into two equal halves, if we cut this sphere into two equal halves, I'm going to have something that looks like this. We'll have it to look like this. You know, we'll have this, where you have just this curved surface, and you also have the cross section here. The cross section. This is a hemisphere. Of course, this is a sphere, and this is a hemisphere. A hemisphere is the half part of a sphere. When you cut a sphere into two equal halves, what you have is a hemisphere. How do we determine the total surface area of this hemisphere? The total surface, total surface area of the hemisphere, total surface area of hemisphere will be equal to the area of this curved surface here plus the cross-sectional area, which is a circular surface. This is a circular surface, and this is a curved surface, and this is the cross-section. So that will give us area of curved surface plus cross sectional area, or area of cross section. I call it area of cross section. Now, when you look at this curved surface, it is not as full as this. This gave us 4 pi r squared because it is the full surface. Now that it is a curved surface for a hemisphere, a curved surface for a hemisphere, just like you can see here. If this is 4 pi r squared, then the area of this curved surface of the hemisphere is halved, which will give us 2 pi r squared. The cross-sectional area of this cross-section here is a circular surface, which is the area of a cycle. So this will give us plus pi r squared. When you add this up, 2 pi r squared plus pi r squared will give us 3 pi r squared. This is the formula for calculating the total surface area of a hemisphere. That says a spherical orange is cut into 2 equal parts, each of total surface area 84/6/7 centimeters squared. Calculate the area of each cross section. This orange is cut. When you cut orange, what will you have? You have something that looks like this. A full orange. If you cut it, you are going to have 2 equal halves of this that I have on the board. Here is the what the question is asking us to calculate is to determine this cross-sectional area. This cross-sectional area is pi r squared. This is what the question is asking us to do for. But we are told from the question that each of them has a total surface area of this. Now, because the total surface area of one part of this, total surface area, the total surface area of one part or half, let me put it as half orange, of the half orange is equal to 3 pi r squared. 3 pi r squared. That's the total surface area of half orange. And we are told that this total surface area is 84/6/7 centimeter squared. Centimeters squared. Okay? So if we put the total surface area here, it means that 84/6/7 is equal to 3 pi r squared. Now, if we work this out roughly, if we work it out roughly, so it give us 594/7 equals 3 pi r squared. Let me, for the purpose of space, if we move this here, I'll divide this here also. If we move this here, cross multiply here, you have that 7 times this will give you 21 pi r squared equals 594 times 1 will give us 594 here. Remember, we're looking for the radius. We want to get the radius because we require the value of the radius here to determine the area of cross section. So here, our r squared here will be equal to 594 over 21 pi. And this is expressed as 594 over 21 times 22/7. 7 will take care of this and you have 3 here. And so r squared will be 594 over 21. Over 66. Over 66. 3 times 22. And this will give us 9. Therefore, our r will be what? Plus and minus square root of 9. And that gives us 3 centimeters. This is the radius. But the question says calculate area of each cross section. This is the cross section of one half of the orange. The other half of the orange also have the same cross section. So one half of the orange, the area of each, cross section of orange will be equal to pi r squared. And our pi is 22 over 7 times our r here is 3. This is r squared, so it will be 3 times 3. And when you simplify this, it gives us 28 whole number 2 over 7 centimeters squared. This is the value of the area of each cross section as requested by the question.